For questions 9 through 11, we're using this home run by Hanley Ramirez. So we're told that the ball was in the air for 6 seconds before landing in the bleachers 50 feet off the ground. The height in feet above the ground of the baseball can be modeled by this equation. H of t equals negative 16 t squared plus vt plus k, where v is the initial upward velocity of the baseball and k is the initial position of the baseball at the time that it was hit. And we're told that it was hit when it was 2 feet off the ground. We're told that k equals 2. So let's go ahead and replace this k with 2. And now question number 9 says, use the fact that the baseball was 50 feet off the ground after 6 seconds to find the value of v and write the equation for the function h of t in standard form. So we're writing this equation. We've already got most of it written. All we have to do is find the value for v, the initial upward velocity of the baseball. Now what this equation is giving us is it's the height with respect to time. And we're told that when the time was 6 seconds, the ball was 50 feet in the air. At 6 seconds is when it landed in the stands 50 feet off the ground. And so if we plug in 50 for the height and then plug in 6 for the time and then solve for v, that's going to give us our initial upward velocity, and then we'll have the whole equation. All right. So here we have 50 equals 6 squared is 36 times negative 16 is negative 576 plus, and let's go ahead and write this as 6v plus 2. And then we can combine this 576 plus 2. That's going to give us negative 574. So we've got negative 574 on this side. We want to move that over here. So let's add 574 to both sides. And so over on this side, we're going to get 624 is equal to 6v. All right, and then divide by 6, and we're going to get that v equals 104. All right, so now we can take that 104 for v, and we're going to plug it back in in this initial equation, and then we'll be done. So let's go ahead and go back to our initial equation. We're going to plug in 104 for v, and that's the equation describing the height of this ball over time. And that would be A for number 9. For number 10, it says find the vertex for the function h of t and explain what that means. So the vertex, if we think about this ball, the height of this ball as a parabola, the vertex up here is going to be the maximum height that the ball reached. So, and remember, to find the vertex of a quadratic function, the vertex of a parabola, we're going to, with this in standard form, the vertex is going to be given by x, or t in this case, because that's our input variable. T is going to be equal to negative b. Remember, this is our a, this is our b, this is our c. When we have a quadratic function in standard form, so we have negative b over 2a, so that's negative 32, negative 16 times 2. And so negative 104 divided by negative 32 is going to give us 3.25. So we know that the ball reached its maximum height after 3 1/4 seconds. So now, if we plug that back in up here, h of 3.25, and then plug all of this into our calculator, we're gonna find that it reached a maximum height of 171 feet. So our vertex is going to be at the point 3.25, 171. After 3.25 seconds, the ball reached its maximum height of 171 feet. And that's going to be B for number 10. All right, now number 11 says, suppose that we want to find out how long the ball would have been in the air had the bleachers not been in the way and the ball could have traveled all the way to the ground. How could we find that? Well, remember that up here, when we were initially trying to find V, we said that after 6 seconds, the ball was at 50 feet. So in order to find out how long the ball, it would take for the ball to reach all the way to the ground, well, we would just plug in 0 for H, because when the ball hits the ground, the height would be at 0 feet. So if we plugged in 0 for H of t, and then solved for t, that would tell us how long it took for the ball to get all the way back down to the ground. One of the most popular mistakes on question number 11 is to say A, evaluate H of 0. That is different. Remember that this inside the parentheses, that's our input, our independent variable. So if we find H of 0, we're replacing that t with 0. So we're saying we're finding the height when the time is 0. And we know what that was. It's 2 feet off the ground. When the height was, when the time was 0, right when the ball was struck, the height was 2 feet off the ground. To find how long it's going to take to get to the back down to the ground, we have to plug in 0 for H, and that is C. Set H of t equal to 0, and then solve for t.